Hello everyone, I hope you all are doing great. My name is Dheeraj Choudhary and welcome back to our series of Python for machine learning and artificial intelligence. In today's video, we are diving into one of the most fundamental building blocks of Python like variables, data types and typecasting. You will learn how Python stores data, what makes it dynamically typed, and how to convert values from one type to another, which is a skill that's absolutely essential when preparing data for machine learning. If you are ready to get hands-on with real Python code, drop a comment saying data mode on. I want to see who is leveling up with me today. So stick around till the end, as by the time we are done, you will not only understand Python variables, but you will also be using them like a pro. So without wasting much time, let's get started. Welcome to our second video on Python for artificial intelligence and machine learning. Today, we are exploring variables, the fundamentals, building block of any program. So we will start with understanding what a variable is. So consider a variable like a labeled box in your computer's memory. The label is the variable name, okay, and the value inside that can change at any time. Suppose if I have a box in that today I am keeping books, tomorrow I will keep groceries, next time I will keep something else. So the values can keep on changing, but the variable names is the box. Just keep that picture in mind. We will take it ahead in our upcoming slides. So now in a below example, you will see we are creating three variables, one holding text, one a whole number, and the last one a decimal. So Python makes this super easy for us in defining variables and no need to declare the data type. Just pick a name, add an equals to sign and give it a value. The data type declaration, Python will do it for you automatically. Unlike other languages, Python figures out the type for you. So let's look at this live example and see how variables work in action. So if I take you over here, so as you can see, I am going ahead and I am just assigning this value to these variables. Now after assigning the value, let's go ahead and check that what kind of variable has been created exactly. So I will just go ahead and run this. This creates the variable. Now the variables are created. Now I will go ahead and print this. So as soon as I print, you will see that for message hello Python, it is a string. It has saved hello Python as a string. Then if we see for counter, it has been saved as an integer, and then we see the last one, that is pi value, it has been saved as an float. So that is automatically done from you from Python. Now let's move ahead and understand about a very important concept that you guys should know in and out as we start working in Python. So let's talk about what's really happening when you create a variable in Python. In Python, variables aren't the boxes holding values, they are the references to the object stored in memory. Suppose when you assign a value to a variable, you are just giving a name to that object. Let's understand this by an example, and here's where it gets interesting. So let's understand that with an example. What I will do is I will take you over here. So right now you know that we have defined the three variables. So how to define? Now we will see how it works in memory. So over here, what I am going to do is I am going to assign a list to A. Suppose if I assign a list to A, what do you think? So A is going to store 1, 2, 3, right? That's what exactly it prints when you go ahead and say print A. So it will give the it is going to give the value of 1, 2, 3. So let me go ahead and run it. So it says 1, 2, 3. So our understanding is inside that box, this is the value that is stored as an object. But no, it is not. So what exactly happens when I say A is equal to 1, 2, 3? It is going and creating an object into our system's memory, and the object where it is being created, A is holding the reference ID to that object. So if I go ahead and print the ID, so this is actually the place in your memory which is holding the value 1, 2, 3. So that is how it works. So when you define a variable, when you say a is equal to 1, 2, 3, at that time 1, 2, 3 is 1, 2, 3 is going to be an object which is going to be stored in computer's memory at a specific location, and your variable name is going to reference to that specific place where the object has been stored in your memory. That is how it works. Okay, so let's understand that if it is storing that in the object, suppose if I say b is equal to a, is it going to create one more object in our computer's memory? Let's see. So what I am doing is I will go ahead and say b is equal to a, and then b is equal to a, and let's see if it creates another object or it is using the same object. So when I said b is equal to a, so our value list value has been assigned to b. Now when I put the id of b, you will see that it is exactly the same as a. So what is happening over here? So this is what that is happening. So when you say b is equal to a or c is equal to a, these all new variables that you're going to create all are going to point to one memory location only. That means the object that you see over here, so this object is stored in your memory, and whatever variables are you creating, and when you're creating that by referencing the other variable, it is not going to create separate object for you. It is going to only point towards that specific object which is already been created. Now we understood that. Now what would happen if I go ahead and change the value in in b? Let's take an example of b. So right now in b, the list elements that we have is 1, 2, 3. I am going to append 4 in b. Okay, and let's see what happens. So when I'm going to append 4 in b, you will see that the value of a has also changed. What's the reason for that? The reason for that is a and b both are pointing towards the same object, and now when you have modified the object for b, it has modified the object for a too, because both are referencing towards the same location of the object which has been stored. So this is how it works. Now another important concept. So and here's where it gets really interesting, when multiple variables can point to the same object. So it is very important to understand one thing, that when multiple variables are pointing towards one object, so when they are pointing towards one object, so usually this change gets reflected only for mutable objects. For example, list is a mutable object where we can append more values into an existing value, but if it is a string, it is immutable. So in that case, it will create another object automatically. Okay, if you are changing any of the values within that specific string that you have defined, that you have to make a note of. Then suppose now you want to use the same values that you have from a, but you don't want to reference to the same location. So in that case, what you can do is, in that case comes another option where you can use copy. So when you say that a dot copy and assign it to c, it is going to copy the value from that specific object, and it is going to store it on a new object location for you. So when I say c is equal to a dot copy, now let's see. So let me go ahead and print it. So over here you have seen that the object id, so the id where the object has been saved has been changed, because it has created a new object now, and now c is pointing to that new object location, not the same object location of a. So if I go ahead now and append a new value into this list of c, so you will see that only c has been modified, a has not been modified. So what we understood from this is, whenever you are going to copy a value from an existing variable, and if you want to create a separate copy of it, instead of referencing to the same value, we have to use dot copy, that is the inbuilt variable. So let's now understand how we should name our variables. So let's talk about variable names in Python, how we should name it. So the first rule says that the variable name must start with a letter or an underscore. After that, it can have letters, numbers, or more underscores accordingly. But you can't use Python keywords like if, for, or, while. Those have special meaning. So those are some reserved keywords that you cannot use. Now, if you want to know the entire list of Python keywords that you cannot use as your variable name, what you can do is you can go ahead and run this command. So this command helps you list down all the available keywords that are reserved keywords from Python. So you cannot use this list of names as the same name for your variable. Just make a note of that. Now, so Python is also case sensitive. So suppose if you create a counter variable, counter is equal to xyz, and then you create one more variable with the same name, but the initial alphabet is in capital, it is going to create two separate variables because Python is case sensitive. Now, beyond the rules, we will follow some naming conventions. Okay, so for regular variables, we use lowercase with underscore. This is called snake case that we use. This is how we define a snake case. Okay. Now, for constants, so whenever you are coding at that time, this is a basic naming convention analogy that as a developer we follow. If we are going ahead and defining some specific variable name in all capitals, it says that this is a constant. This is a value which does not keeps on changing again and again. This is a constant value that we are going to use now. And when we get into classes later on, we will use camel case. So camel case means the first, as soon as we start, it starts with a capital letter for the class name declaration. Now, why naming convention matters? Because good names make your code more readable. So let's understand this with an example. Suppose if I say A is equal to Alex, it's very vague. You won't understand what exactly A is, what kind of variable it is. But when I say username is equal to Alex, that makes sense. That is how you use it. And in the field of artificial intelligence and machine learning, when things get too complex, clear names are the lifesaver for us. So we have to make sure that we follow this analogy during our journey of learning Python for machine learning. Now, coming to a very important part, that is dynamic typing system in Python. So usually when you define a variable in C language, for example, so what you will say, integer x is equal to 42. You are defining it with the data type itself. Now, if you want to save a string value in that x, it is not going to change. Here comes Python, where what Python says that Python uses dynamic typing, which means you don't have to declare variable types. So variable types. So if you will see in the example below, x is equal to 42. Right now it is integer. Then I say x is equal to hello, it became string. Then I say x is equal to 1, 2, 3, it became list. So it is dynamically assigning it at runtime. So this makes Python super flexible, especially for quick data exploration that we would require while we are going to develop our models in machine learning. But you have to be careful that this flexibility can also lead to some bugs. So as you grow, you will learn how to balance that power of dynamic typing system in Python. And Python also supports some optional type hints that we will explore later. Now, let's talk about type checking and conversion. This is again a very important thing that you should be aware of. Sometimes in Python, you need to check what type of value is, or even convert it. So to check the type of value, you use an inbuilt function that is type. So when I say age is equal to 25, so now if you are a layman, you don't know what exactly 25 is being stored as. So when you say type is equal to age, it will say that it has been stored as an integer. Okay. And to check if the value is a specific type, you can use is instance. In that case, it is like a if loop that you write to understand, if condition that you write to understand whether it is an integer or not. We usually use this kind of method in the code where we are going to use inheritance. So let's go ahead and see that how those two different functions are going to work. So here I say age is equal to 25. That means whenever this age is going to get created, automatically it is going to be created as integer. So when I say print type age, what it is going to do is it is going to go ahead and print the data type of age. So the data type of age value is integer, and and when you use is instance, what is instance is doing is, it is like a if condition. It says that if age is equal to integer, then return true. So that is what it has done over here. So it went ahead and checked whether age is an integer, and this is the output that it has given. Now let's talk about Python inbuilt functions for data conversion. We will see it one by one. So first we will talk about type conversion of so first what I will do, I will define a variable. So once a variable is defined, let me go ahead and print, so you know that what value have been saved. So right now this has been saved as an integer. Okay, so let's start using the different functions that you see over here, that is int, float, str and boolean. So right now it is str. What we are going to do is we are going to convert this string to a float. So for doing that, what we are using is, we are using an inbuilt library which is float. What it is going to do is, it is going to change the value of price str, that is string, to a float. So let me go ahead and run this, and over here you will see that this string, that is class str, has been now converted to a float. That is how you can use convert the data type of a specific value by using this inbuilt functions that is available in Python. So now previously we were using price str, which was a defined variable from our end. Now what we will do, now for converting float to integer, I am using a constant value directly, that is a hard-coded value. So over here what I am saying is quality is equal to integer 4.7. Now 4.7 is a decimal, that means it is a float. So what this integer is going to do is, when it is going to save the value to quantity, it is going to go ahead and remove the values after the full stop. So after the decimal, nothing is going to be available. So let me go ahead and run this. So that is how it has converted this value, that is 4.7, from float to an integer, that is 4. Now let's talk about boolean. What boolean is? Boolean is a value which says true for non-zero. If you say 1, 2, 3, 4, 5, 6, 7, 9, 10, all those will be considered as true, and false will be 0. So what we are doing here is, we are going to create a variable where we are going to use the function bool, and this is going to convert this into a boolean. And if I run this, you will see that this 1 has been converted to true. So this is how you can convert a integer to a boolean. Now let's convert a integer to a string. So to convert an integer to a string, what we'll use, we are going to use str, that is again an inbuilt method. So over here, this is the integer. So str is going to convert this 42 from integer to string, and it is going to save it in item code. Okay, so now let's understand why we have to do why we have to do type conversion. So a common use case is when you are going to use a user input. So whenever you take an input from a user, for example, if I say user input is equal to input, enter a number. So whatever it is going to return, it is going to by default return your string, but you want to have a number, right? So if your logic is going to be running on an integer, you cannot give string, otherwise your program will fail. So in that case, type conversion functions matters, and you have to be careful that not all conversions are going to work. For example, if I go ahead and say like this, let's go ahead and create one code. If I say integer hello, do you think it is going to work? No, it won't work, because you cannot convert a string to a integer. So this kinds of, suppose if it would have been 10 inside this, it would have converted. But right now we are going ahead and asking to convert hello to integer, which is not possible. So we have to make sure that this kind of value errors or this kinds of limitation we understand beforehand, because in artificial intelligence and machine learning, you will do a lot of type checking and conversion, especially when you're cleaning the data from the files or the APIs that we are calling. Now, let's go back to our slide. So now we are going to talk about numeric data types, that is integer and float. So an integer is a whole number like 5, -3 or 0. In Python, there is no size limit like we have in other languages. So integers can be as huge as long your memory allows it. You can even use underscores to make big numbers easy to read like this. So instead of writing this all together, when you're putting it underscore, it becomes readable. You can do that too in Python. And floats are numbers with decimal, that is like 3.14, like this is a decimal 98.6, right? So Python floats follow the IEEE 754 standard, meaning 15 to 17 digits of precision. So after the decimal, you can use 15 to 17 digits. For that, the precision would be, till that time, the precision would be allowed. Now, you can also use scientific notations over here. So if you see this 6.02 E23, so this is a scientific notation that has been used over here. So in precision critical task, like in finance, you have to be mindful of using floats for making a calculation. Let me give you an example. So for that, let me go ahead and open our REPL. So the REPL is opened. Let me get it over here. So if I say 1 plus 1, it's 2, right? It is giving the proper calculation. But what if I say 0.1 plus 0.2? It should give 0.3, right? See, it gives, at the end it is 4. So you have to be mindful of making calculations with float data type. Now let's go back to our slide. Okay, just give me, yes. So our next one is understanding strings. So this is going to be a long topic, because in this we are going to have a lot of examples. So strings are one of the most flexible data types in Python, and they are everywhere in machine learning. A string is just a sequence of characters wrapped in quotes, single quotes, double quotes, or triple quotes. So over here, you can define strings like this in double quotes, then you can define string in a single quote, as well as you can define the strings in triple quotes like this for multiple line comments that you want. And you can also combine strings, that is, you can perform a concatenation operation between two different strings by using a plus sign. Let's go ahead and see that. So I will just go ahead and close this. So over here, you can see that we have defined our strings, and this all gets saved immediately. Now let's talk about concatenation. So what we have done is, so right now, hello is one key, hello is one string, Python is one string, and this is also one string. So we are concatenating 3 strings together. And when we go ahead and run this, you will see hello Python. all together, because this is how the plus operator in strings work as a concatenation. Okay, now let's talk about another one, which is, suppose if you have to do repetition of the existing string that you have. In that case, you can multiply it. You can use multiplication to 3, 4, 5 as per your requirement. So right now, if I have Python as a keyword, and if I say into 3, it is going to print Python 3 times. So that is how you can do repetition. So now, what if you want a specific character from a string? So in that case, you can use indexing. But always remember, whenever you are using indexing, the index starts from 0. So for example, if this is the message, and message we have defined over here, right? So let's see what is the indexing for this message. So it starts with 0. So at 0 we have H, so it is 0, then E is 1, L is 2, second L is 3, O is 4. So this is how it goes accordingly, but it starts with 0. So when I go ahead and say print message 0, it is going to give us H, because H is at the index of 0. So let's go ahead and run that. This is how you can use indexing with your string that you have defined. Now let's talk about how you can slice your string. So for slicing your string, what you do is you start from the place where you want, but it is going to be it is going to end with the number that you're defining -1. So for example, if I say 7, so first let's see what is on the index 7, which is the character. So this is 0, 1, 2, 3, 4, 5, and this space is also going to be considered 6, and P, that is Python. Python starts at 7, and once it starts at 7, then it goes to 8, 9, 10, 11, 12. Okay, so with what we are going to do is we are going to go ahead and say 7 to 13. It is going to slice the Python keyword for us. Now when you want to check the length of a specific string that you have defined, at that time you can use the inbuilt method from Python, which is length, which tells you the total number of characters present inside your string. Okay, now here is something that you should be aware of. So strings are immutable. You can't change them in place like we do for list. So every change creates a new string. So for example, if I say hello Python and I go ahead and say that let me go ahead and change the P to T, it is not going to change it in the existing object. It is going to create a new object out of it. So you have to be aware of it. And why does that matters in string? Because in the text heavy work like data science and natural language processing in machine learning, this impacts how you handle large amounts of text efficient data. Now let's go ahead and see another one, that is Boolean values. Boolean is again a data type. So Booleans are very simple, just two values, true and false, but they power a lot of Python's logic. So they are named after George Boolean, who invented Boolean in algebra, the base of all computer logic. So in Python, true and false are capitalized. That means whenever you write true as a Boolean, it has to start with a capital one. So it is going to be capital T inside true, as well as capital F inside false. So you can also use comparison operators like is equal, like the other one is not equal to, greater than, less than, and all these are going to return Booleans to you. So when you say, for example, if I say age is equal to 25, and if I say is adult is equal to age is greater than equal to 18, it is going to return true. And if I am going to use it greater than equal to this, it is going to return me false. So over here you can use it in a comparison operations also, as well as you can use it in logical operations where you can check by giving a condition over here. Now let's understand another important concept, that null value of Python. So none means no value. It's the Python way of saying nothing here. So it's not the same as 0, an empty string, or false. It's a special thing that is available in Python only. When you want to check if something is none, you use the word is not equals. So you will see none used when a function doesn't return anything, or a placeholder when data is missing. In data science and artificial intelligence, it's super useful for handling incomplete data before cleaning or analysis. And none may seem very helpful for handling a task like this. So let me show you none with an example that how it is used in real time. So if you go over here, so in the code, so if I say result is equal to none, it is going to save it as none. And when I'm going to print it, it will give the same output as none. And how I can use it? So I can use it with is method, where I will say if result is none, print no results yet. So this is how you can use it over here. And when you want to use it in more advanced version, what you can do is you can suppose over here what I have done. First, I have defined a function. I know we have not covered it right now, but consider this as an example for your understanding. Whenever you write a function, what we do is over here I say defined find user. I am defining a function where I say if username is equal to admin, then we are going to return this information. Otherwise, we will return none. And over here, what we say that we call this function, and the value that we get from this function, we store it in user variable. Once we store it in user variable, then we use a conditional use if for doing the checking, condition based checking. And over here if we say if user is none, print user not found, and that is what is happening over here. So this is how you can use it in advanced version. So this is one of the very key component that you would be using in programming again and again. So you have to take it seriously. Now let's see what's next. So we spoke about a lot of things, but now when you're working with Python's data type, it's easy to run into some common errors, especially at the beginning. To avoid this, make sure you convert the types clearly, check your inputs, and handle special cases like checking if the denominator is 0 before dividing. So as you get more advanced, you will use try and except blocks that we will cover later to handle the errors more gracefully. So this becomes especially important in machine learning, where wired input values are missing and can be easily used to crash your code. So you have to be very focused towards using this data type conversion. So let's understand, if you are not using it properly, what kind of errors you get. So for example, if, as I said, you cannot add a string and an integer. So over here what I'm doing is I am adding a string with an integer, and you will see you will get an error that is for incompatible data types. So this is how this is the limitation that you should be aware of. And when I say integer hello, as I said you before, you cannot convert this string into an integer, right? So it is again going to give you an error over here. See, value error. And you cannot divide any number by 0. This is a limitation in Python you have to be aware of. So if I go ahead and say 10 divided by 0, it is going to give you a 0 division error. So these are some of the errors that you should be aware of. So in today's video, what we covered? So we covered variables as named references to value, core data types like integer, float, string, boolean, and none, and the type checking and conversion with basic input-output operation. I hope this helped you to understand all the basic concepts. Further, we will discuss about more about logical operators in our next video. Thank you, and if you have any questions or queries, please don't forget to put that in the comments below. Bye for now. Thank you.